So good morning, everyone, and welcome. My name is Kim Cameron. I'm one of the business engagement managers at the Industrial Biotechnology Innovation Centre, and I have responsibility for the delivery of the Bioeconomy Cluster Builder project. We're delighted to partner this morning with the UKRI Interdisciplinary Textiles Circularity Centre on today's webinar, Transformation of Local Bio-Based Waste Streams into Circular Textile and Building Materials. Before we begin our presentations, I'd just like to run through a few brief housekeeping points with you. All participants will be muted throughout the webinar, but when we come, please use the chat function for submitting any questions for the speakers as we proceed through the webinar. But when we come to the Q&A session after our main presentations, if you'd like to come off mute, please just raise your hand and address yourself directly to the presenters. Please use the chat box for any technical issues also. So if you have problems with sound or visuals or any other issues, please let us know through the chat box. And the webinar will be recorded and you'll be sent out a link to the recording along with any other materials in due course. We collect equality, diversity and inclusion data for the events that we run. So I'll shortly share a link to a brief survey also in the chat box. So turning now to our agenda for this morning, we'll be together for around 2 hours in total. And in a moment, I'll give you a brief introduction to the Bioeconomy Cluster Builder. Then we'll move to Dr. Miriam Ribul, who will give us an introduction to the UKRI Interdisciplinary Textiles Circularity Centre. After that, we'll hear a series of presentations from our guest speakers. And then we'll move and have some opportunity for Q&A before we move into our breakout rooms. We'll make every effort to assign you to the breakout room preference you indicated at registration, but if there are any issues, please let us know and we'll try and resolve that for you at the time. And then after that, we'll have some closing remarks and we'll close around midday. So as I mentioned earlier, I'm part of the business engagement team at the Industrial Biotechnology Innovation Centre, and I've got responsibility for delivery of the Bioeconomy Cluster Builder. So I'll give you a bit of a brief introduction to the project to help you understand our key aims and some of the services that we offer. The BCB is a 3-year ERDF funded project, a collaboration between the Industrial Biotechnology Innovation Centre, Innovate UK KTN and Scottish Enterprise. And it was created to support the delivery of Scotland's National Plan for Industrial Biotechnology, which aims to grow the Scottish bioeconomy to a turnover of 900 million by 2025. Joining us later on for the breakout sessions are my colleague Lindsay Dunbar and Dana Helt and Rajesh Mistry from Innovate UK KTN, and the 4 of us work closely on the delivery of the project. The project has 3 interlinked strands aimed at supporting the growth of the Scottish bioeconomy. We've raised awareness of the benefits and applications of IB, and so biotechnology has been applied in a diverse range of contexts, from traditional brewing and baking industries through to the production of advanced biofuels, biomaterials and specialty chemicals. And as we'll see today, by harnessing natural processes, biotechnology and the wider bioeconomy can deliver sustainable alternatives to many of the harmful carbon-intensive products we use every day. We also connect people and resources, so by bringing together the knowledge, expertise and extensive networks of the 3 partners I mentioned earlier, the BCB connects the right people and resources to support the development of new value chains. So that could be things like connecting a commercial challenge holder with an academic solution provider, help with supply chain challenges, or working with a business to identify new sources of funding and investment. And basically, if we can't solve a problem ourselves, chances are we can connect you with somebody who can help you. And so turning to our 3rd strand, we encourage the utilisation of Scotland's bioresources. So 6 feedstocks were identified in the national plan as being key to the development of Scotland's bioeconomy. In essence, these are the raw materials that biotechnology processes turn into the useful products I mentioned earlier. So these feedstocks are things like crop residues, municipal solid waste, whiskey co-products, and food processing waste. And iBioIC, Zero Waste Scotland and Scottish Enterprise have created a bioresource mapping tool, which provides data on potential quantities and locations for these important resources. And here at the BCB, the team can provide tailored reports for those of you that are interested in developing value chains using these feedstocks. So how do we do all this? We deliver targeted events and workshops like today's. By bringing together communities that may not normally engage with each other, we aim to spread the message that biotechnology can provide solutions to many of our net zero challenges. So we've run events focusing on things like net zero chemical manufacturing, bioplastic, packaging, and construction. Our next workshop's on Thursday, the 19th of May, and that will focus on seaweed innovation, and registration for that is now open, and you can find details on our website. I'll put details of the website up at the end of the presentation. So we also deliver events covering more tangible innovation support, so topics like investment, life cycle assessment, and intellectual property. And at the moment, we're developing an event scheduled for late June that will look at digital marketing and the bioeconomy, and registration for that will be open shortly. You can find details about our future events on our website, along with recordings of past activity. To complement this activity, we directly support SMEs in the development of products and processes. So this could be through tools like the Innovate UK KTN Innovation Canvas, or perhaps by pulling together things like focus groups to bring together relevant stakeholders. As I mentioned earlier, we can really leverage the extended networks of the three partners to find the right business support and guidance to help you develop your idea or proposal. And really following on from this, we offer signposting and support in accessing funding from a broad range of resources, including the enterprise agencies, UKRI, IBioIC, and Zero Waste Scotland. And we're also busy building a network of investors and building connections there. So that's a whistle-stop tour of the Bioeconomy Cluster Builder. Please put any questions you have about the project into the chat, or reach out to me directly by email or through our website. I'll put those details in the chat shortly. Just before I hand over to Miriam, I wanted to let you know about the forthcoming IBioIC conference, which will take place in Glasgow on Monday the 6th and Tuesday the 7th of June. We're back in person this year and really looking forward to seeing some familiar faces and of course welcoming some new ones. And this year we're considering the power of biotechnology to support the just transition to a net zero economy. So the conference brings together a diverse mix of delegates drawn from business, academia and beyond. Tickets are on sale now via our dedicated website. And again, I'll put details of that in the chat shortly. So that's enough from me for now. I'll hand over to Miriam Ribul for an introduction to the UKRI Textiles Circularity Centre. And following on from that, we'll hear from our guest speakers. So hope you enjoy the rest of the webinar, and over to you, Miriam.
Thank you so much, Kim. I'm going to share my screen. So, okay. So thank you very much, everyone. Good morning and welcome. I would like to thank the Bioeconomy Cluster Builder, as well as the KTN for the invite and the wonderful collaboration in putting this event together. Today, we will hear a range of novel approaches for transforming local bio-based waste streams into textile and building materials. I'm Miriam Ribul from the Materials Science Research Center and the Textiles Circularity Center at the Royal College of Art, and I'm delighted to introduce you to the event today. Why is a circular economy or bioeconomy relevant today? The landscape of textile and building materials is still rather bleak. The global construction industry accounts for about 11% of all global emissions. The fashion industry is responsible for 10% of global carbon emissions, which is exceeding aviation and maritime shipping combined. We all know that we need to move away from oil, but 62% of textile fibers are still produced from oil, of which 52% is polyester. And there's a myth of recycled polyester, which is also produced from PET bottles, so still reliant on oil. And less than 1% of textile waste is currently recycled into new clothes. So what we need is a different model than the linear production, consumption, and disposal of textiles and building materials, where the end of life of a material is not considered. In a circular bioeconomy, we have new opportunities for keeping resources in a closed cycle or loop. Hence, we explore opportunities for local bio-based waste feedstock in the approach of the UKRI Interdisciplinary Textile Circularity Center, which is one of 5 interdisciplinary circular economy centers funded by UK Research and Innovation, and is design-led by the Royal College of Art, as well as the only textile center within the NICER program. The Textile Circularity Centre envisions a future circular textile economy for UK small and medium apparel fashion industry. Our resource flow are 3 different bio-based waste streams abundantly available in the UK and globally, namely crop residues such as straw, the biological fraction of municipal solid waste, and such as cardboard or paper, and post-consumer textiles waste such as viscose and cotton, which are some of these waste streams, but Kim also identified for the Scottish context, so there's relations there. We take a systemic approach of 3 research strands from Materials Circularity research strand, which I co-lead with Professor Simon McQueen-Mason from the University of York, and I will introduce you to this research strand today, through to circular supply chain to enable and manage information and value flows using supply chain and technology, and to consumer experience to design experiences of textile circularity using digital tools at various points of consumption. The Materials Circularity research strand develops the processes and opportunities for local transformation of waste into circular and sustainable textile materials. I will introduce you to the team, approach, and work packages. We propose alternative courses of actions with materials in textile circularity, in which we solely use waste for clean, social, and on-demand textile material production, in which textiles are designed for reuse and regeneration, and in which environmental impacts are dramatically reduced. Today we will hear more about the importance of creativity and design, in particular in new technologies such as biotechnology for textiles. Designers can uncover new possibilities by seeing a holistic picture of a system and making technology more accessible. In the Materials Circularity research strand, designers are integrated at the forefront and collaborating in all stages of a materials life cycle, from biorefinery for recycling to fabrication and use, in order to develop innovative interdisciplinary methods with materials. The event today will demonstrate the role of creativity and design in funding new opportunities for textile and building materials. We work with designers and an amazing network of partners across multiple disciplines using technologies and processes such as biorefinery, led by the University of York, fiber regeneration and spinning at Cranfield University, near-net fabric manufacturing led by Professor Prasad Patluri at the University of Manchester, additive textile manufacturing led by Professor Paolo Bartolo at the University of Manchester as well. And then also everything is analyzed and the whole circular system assessed through whole life cycle assessment by Professor Phil Purnell at the University of Leeds. The strand has 3 main work packages, which I will briefly outline. In the Materials Circularity research strand, we see opportunities of biorefinery and biotechnology to enable a circular economy beyond biodegradation, but for reuse and circularity of resources using low-impact processes. Dr. Alexandra Lano is joining us today and will describe these processes led by the University of York in detail. Using waste feedstock, we establish new material processes and properties in zero-waste manufacturing methods that can be embedded locally within cities through new machines that can make use of different waste feedstocks through 3D printing, as well as hybrid non-woven and woven approaches using yarns and fibers resulting from clean fiber spinning with natural dyes. And finally, we also explore the maintenance of materials and the future circularity beyond recycling, given that we need to extend the use of the materials through repair and upgrading, and we find new approaches to achieve this using interdisciplinary collaboration between biotechnology, design, and materials science. Before introducing you to the speakers, I would like to thank the Materials Circularity Research Strand and the Director of the Materials Science Research Center and Textile Circularity Center, Professor Sharon Borley. You can follow announcements of our events and hear news on our LinkedIn UKRI Interdisciplinary Textile Circularity Center page, and our contact is tcc@rca.ac.uk. Now I'd like to introduce you to our speakers. Today you will hear a range of perspectives from the creative and scientific communities as they consider design and manufacturing opportunities in these rapidly evolving areas. In particular, I would like to highlight that this is an amazing panel of speakers working in biotechnology, as well as researchers, founders, and entrepreneurs finding solutions and opportunities to bring about change in a range of sectors and local contexts. We will hear from Dr. Alexandra Lano, a senior researcher at the University of York and academic partner in the Textile Circularity Center, who will present the development of a technology platform to transform wastes into circular and low carbon materials for textiles. Rosa Whiteley is a designer and researcher working as part of the Klimavor project of Turner Prize Award finalists' cooking sections, as well as a graduate from the MA in architecture from the Royal College of Art. And she's worked on a range of international projects to explore the relationship between architecture, the environment, and food networks. Dr. Dawn Ellams is the Future Fashion Factory Research Fellow at the Royal College of Art and will present the research program which supports a variety of industry-led R&D projects, bringing together industry and academic partners to solve commercial challenges. This will be followed by 2 presentations of funded Future Fashion Factory projects, such as Aurélie Fontaine, presenting local production lines for manufacturing mycelium leather on an industrial scale and adopting a circular model. And she's also trained in the MA Fashion Design course at the Royal College of Art. Rachel Coase aims to perfect UK-made commercially viable biodegradable sequins in the sustainable sequin company she founded. Last but not least, Renuka Ramanuyam will review the progress of the WHOIT project she founded to develop innovative materials from waste onion skins. The presentations will be followed by breakout sessions aimed at fostering new connections and collaborations. Thematic areas will explore new opportunities and challenges in the themes of new material properties and processes, the integration of waste-derived biomaterials in existing technology and supply chain, opportunities for local transformation of bioresources in circular materials, and funding for materials innovation. And these themes will probably also be relevant across the talks today. I'm delighted to pass on to our next speaker, Dr. Alexandra Lano from the University of York. Thank you.
Good morning. I'm going to share my screen. So good morning, I'm Alexandra Lano from the University of York, and as introduced by Miriam, the University of York is part of the Materials strand of the Textiles Circularity Center. And what we want to do in York is to develop a process to transform bio-based waste into new clothes. So these are the waste stream our lab has focused on. We are a plant cell wall lab and we have been focused on plant-derived waste. So paper and packaging are made of wood pulp. But interestingly, textiles such as viscose, rayon and lyocell are also made of wood. Cotton and cotton-derived fabric are obviously plant-derived, and so are agricultural residue. We're also working with the organic fraction of general domestic beans because this one contains a significant amount of contaminated packaging and also leftover from food material. And what we have focused on within this plant-derived waste stream is, and what we're interested on, is that they all contain significant amount of cellulose. For example, textile, which are made of wood and cotton, contain 35 to 95% cellulose. Straw, such as barley straw, contain about 32%, and the organic fraction from general rubbish contain about 37% of cellulose. So what is cellulose? Cellulose is a molecule common in plant. It exists as fiber, which are long and thin part of plants, which are themselves made of smaller microfiber and even smaller macro and microfibers. And at the end, they are themselves made of individual cellulose molecules, which are long chain, made of only one component, and this component is sugar. And the aim of our lab is to use the sugar from cellulose to make new product. Now, there is a problem with that, is that while us as humans and many organisms can eat sugar, we cannot eat cellulose. So as biologists, we looked into nature. And what you can see on this slide on the top left is a Ribul. It lives in coastal marine environment and feast on wood. It can eat wood from boats and piers, causing considerable damage. So while we don't want to breed Ribul's in York, what we want to do is study these organisms, because the other advantage of a Ribul is that, in opposite to us, when it digests the wood, it doesn't use microbes in its stomach. It actually produces all the biocatalysts that it needs to digest this wood. So at York, we are, for example, studying Ribul to try to find a specific biocatalyst to transform cellulose into sugar. The picture on the top right is more common organisms, and what you can see is a redwood tree which has been infected by honey fungi. And as you can see, the fungi have been able to eat the wood. Now, if we can use this biocatalyst and made sugar from the cellulose, what we want then is to use this sugar and feed it to microbes to make new product for our use. And what you can see bottom left, it's a microbe, it's a yeast called Saccharomyces cerevisiae, and it's what is used to transform barley sugars into whiskey. One on the right, it's a different microbe, it's a bacteria, and this bacteria use sugar to produce cellulose. So what we are developing in York is a circular cellulose concept. And our concept is based on using waste cellulose feedstock that we would then digest to produce sugar, ferment them into a new product, and in our case, we would like to produce new cellulose that we would spin to make yarn and fabric, and transform this into regenerative textile. So I'm now going to go through every step to demonstrate this concept. The first step is to transform the cellulosic feedstock into sugar. So the biocatalyst who can transform cellulose into sugar is called cellulase, and it's an enzyme. And enzymes are fantastic. They're found in nature, so they are not toxic. They are highly specific, and this will be important later. The cellulase will transform cellulose into sugar, but they will not touch any of the other components of our feedstock. And because we work with waste stream, our feedstock are generally not pure and contain other components. So, for example, in agricultural residues such as barley straw, you would find hemicellulose and lignin, and this will not be affected by the cellulase. Also, cellulase can be engineered to be more specific or more efficient. But cellulase have been studied for centuries and they are used commercially. They are actually the second largest industrial enzyme produced per dollar volume. And they're used in several industries such as detergent industry, animal feed and paper industry. So it's possible to buy them as cocktail. The second step is to transform the sugar into cellulose. And this is done by fermentation by a bacteria which is called Comataga Aebacter xylinus or Acetobacter. These bacteria have been known also for centuries because they are the bacteria which transform wine into vinegar. They are also part of the consortium of microbes which is used to make kombucha tea. The product from fermenting cellulose into sugar to make new cellulose makes bacterial cellulose. And again, this is already commercially available. It's used in Indonesia to make puddings called nata de coco. And the cellulose produced is extremely strong and it grows as large layers of very strong cellulose. It's used by Sony to make loudspeaker cones. It's also very good at absorbing water. So think about very, very absorbing tissue paper. And it's been used to make medical wound dressing. The next step would be to transform the cellulose into a yarn. So that may seem unusual, but what we know is that man-made cellulosic fibers such as viscose, rayon, or lyocell are made from wood cellulose. In this process, the wood chip, the cellulose is extracted from the wood chip and transformed into dissolving wood pulp using chemicals. this cellulose pulp is dissolved and spin again to make viscose, such as the scarf on the picture. So what we are developing is a process to transform bacterial cellulose into textile fiber and yarn. The next step will be to transform this yarn into regenerative textile, and this is something that Miriam has explained. To produce regenerative textile, it will be important to develop new design, more circular design, and we are collaborating with TCC and with company who are developing new way to make clothes to avoid, to help make the clothes more regenerative, to help recycling. And for example, the idea is to avoid using more than one type of fiber or to mix fibers with polyester. So have clothes been made from bacterial cellulose? Yes, they have, but not that many of them. So what you can see on the left is a project called Bioeconomy, which is growing a wardrobe from bacteria and was presented by Susan Lee. And what she did is use bacterial cellulose to make clothes. So while it is very pretty, it's very difficult to make at large scale. And because cellulose loves water, it's not the best clothes to wear under the rain. But bacterial cellulose has been transformed into yarn and textile by a company called Nanolose. And what you can see here is the dress that they produce. So what Nanolose has done is produce the bacterial cellulose from sugar. So that's different from us when we want to use waste stream to produce this cellulose. But they are demonstrating that it is possible to spin it and transform it in beautiful clothes. So here is the circular cellulose concept. We start with waste stream, goes to sugar, bacterial cellulose, yarn, and regenerative textile. So while I have presented the concept that we are developing, I will now show you our progress. So what you can see here is bacterial cellulose made from waste straw. So we've developed the process and scaled it up and optimized it so that we can produce up to 500 grams of bacterial cellulose per month from waste straw. We've also optimized the fermentation and washing of the cellulose, so we obtain almost pure white cellulose. As you can see here, the bacterial cellulose grow in a very large sheet. And at the moment, we are growing it statically, but we are looking into scaling up this process and move towards submerged fermentation. We have also developed demonstrating our process with waste textile. So this is demonstrated here. The first picture on the left is some purple viscose. After digestion using our enzyme cocktail, we obtain a colored syrup solution. And what is interesting here is that all the dyes have come out in the solution when the textile was digested. Following fermentation with the bacteria, we obtain purple bacterial cellulose. And here, what is important is that the dye didn't affect the bacteria. And the last picture shows the bacterial cellulose following washing. So the dye didn't bind to the new cellulose. So what is interesting here is that from a waste stream containing cellulose, we could produce virgin pure cellulose that we hope to use to make new textile. So the transformation of bacterial cellulose into yarn is not an expertise of the University of York. And to do this work, we've collaborated with several universities. So we had a project with the RCA when we tried to weave the bacterial cellulose as it was. And it's the bottom left picture, and you can see a denim-like material made from bacterial cellulose. The bottom right is a project funded by BBSRC and UKRI when we use more common solvent to spin our cellulose. And the two top pictures are a project within the Textiles Circularity Center. On the top right, At the University of Cranfield, Sami Rahateka has developed a way to spin our bacterial cellulose using ionic liquid, while in Manchester, the team of Paolo Roberto has used 3D printing to obtain yarn-like material from our bacterial cellulose. So we're going to now develop this process and try to scale them up. So the strength of our approach is that we can use organic bio-based cellulosic waste streams to make new clothes. This adds value to cellulose waste streams and reduce the use of virgin resources. So every year in Britain, we use about 1 million ton of clothes and we dispose of 1 million ton of clothes. So if we can replace any of these clothes with textile made from waste stream, we would reduce the use of virgin resource significantly. This enables the material circularization of textile and sidestep problem associated with recycling. So as you could see when I demonstrating our work with textile, we didn't need to decolor the textile before we recycle them. And this is an advantage in comparison to chemical or mechanical recycling. We also use environmentally benign technology because enzyme and bacteria work around 30 degrees in water. They don't need dangerous or toxic solvents. So if by developing this project, we hope to defossilize the textile industry, create jobs, and reshore manufacturing. Thank you. And I welcome any question at the end of the presentation. I'm now going to pass speaking to Rosa Whiteley, which is going to present the Climavore project. So I need to stop sharing. And welcome, Rosa.
Thank you, and thanks for the presentation. That was great. Hi, everyone. I'm Rosa, as was said. I'm just going to share the screen so I can start the presentation. So just checking that you can see my first screen. Great, okay. Sorry, one second. And you can still see it now? Cool, that's great. Okay, so I'm Rosa. I'm a project manager and researcher for cooking sections, and I'm here with you to present the Climavore project. Sorry, I might have to present it like this, where you can slightly see the sides, just because I need my notes. So I hope that's all right. So Climavore is interested in how we eat as humans change the climate. And since 2016, we've been working on Skye, on the Isle of Skye in Scotland, to think about the possibilities for regenerative aquacultures, meaning how we can think with seaweeds, oysters, and mussels to imagine new ways of using the coast, which currently is being exhausted by pollution and exhaustive aquaculture, such as salmon farming. So this image that you can see here is the first step in the project in 2016, which was an installation appearing and disappearing with the tides in Portree in Skye. At high tide, it functioned as an underwater oyster table with filter feeder bivalves and seaweeds. And at low tide, it emerged as a dining table for people to discuss and understand more about regenerative aquacultures. Just to be clear, regenerative aquaculture is slightly away from the biomaterial. Regenerative aquaculture is about oysters, mussels, and seaweeds and filter feeders, which filter seaweed as they grow and clean the seawater. They also act to improve ocean biodiversity, increase oxygen in the water, and act as a carbon sink. They're rooted locally, highly nutritious, and don't need chemicals or feed to grow. So they don't need fertilizers or feedstock and things like this. And just like you can see in this image, bivalves such as oysters can clean large amounts of water as they feed off the water throughout the day. So from this project and from this oyster table, Climavore Community Interest Company was formed with the aim of promoting education and research of coastal ecologies. To give you a sense of where we are today, because this was back in 2016, we're now running Climavore Community Interest Company with 3 strands. And these 3 strands are learning, growing, and building. And whilst I'm here to talk to you about the building side and about the material involved, to form our circular economy, I'll briefly explain to you how the learning and the growing feed into this. So the learning side of this is we have Climavore cooking workshops and we have Climavore apprentices within the Isle of Skye that work with restaurants that have signed on to becoming Climavore, which means they work with recipes and work with food that we encourage them to serve, as opposed to salmon and as opposed to kind of damaging food ingredients. So these restaurants work with local school kids and work with apprentices to develop this like learning arm of Climavore. And then growing is our other arm. And this is a model we're developing for growing regenerative food in the intertidal zone. And the ambition for this project is to work with community trusts and private individuals to create a community-owned and run seaweed and mussel farm within Skye that will create new opportunities for work, food produce, and new ways of thinking about collective use and ownership of the coast. And this food that is produced will also go towards the Climavore restaurants that we're engaging with within Skye. And we call this CLIP, which stands for Closed Loop Intertidal Polyculture, much easier to say CLIP. And so Climavore building is the 3rd strand, and it fits into these other activities in Skies in many ways, which I'll explain. And you can't really understand this building side of Climavore without understanding the others, because we approached this building project in order to close the loop in our intertidal growing system. And we were interested in how we could recuperate and repurpose local food waste that would be developed from the food that we're encouraging to be eaten and sold, and repurposing it into new composite materials with the aim to develop building and interior materials using products from the coast of Skye made almost entirely from waste seashells. And this isn't anything necessarily new on Skye or elsewhere. There is a lot of building materials and building practices that develop from coastal materials and waste food practices. So coastal environments have provided materials such as seashells, shell lime, and seaweeds for millennia, which have been used for the construction of roads, foundations, floors, walls, and roof technologies within Skye and throughout coastal communities in the world. And the development of these novel techniques is of growing importance as they use material with a minimal carbon footprint, providing alternatives to cement, which is really important as cement and concrete industries are like a key contributor to carbon dioxide pollution and carbon in the world. So these are many examples of these different techniques throughout the world that use shell and seaweed as a building material. And these have informed our research and informed our development within Skye that has been going now for 3 or 4 years with a local craftsman and a Climavore Builds apprentice. Great, yeah. So the Skye-based research has been developing since 2017, and we've been working with restaurants to collect shells and build a system where we can collect shells from them in a easy way and wash, crush, and develop them into shell lime and aggregate to make an alternative concrete. So a lot of this processes over the years have been to develop this cycle and develop this ability to work with a number of players within Skye to collect the shells and clean them. And we basically use shells and shells are able to be cement because they're so calcium rich. So shells are all calcium carbonate, and calcium carbonate is kind of like the center ingredient for many structures on Earth. It's like the center ingredient for our bones, for rocks, for mountains. And our approach is basically to try and reform the main ingredient of shells and the solid composite of shells into products and into tiles and into bricks. So we crush them, we grade them, we fire them to make lime, which is a key ingredient in concrete and a key way they've been used in the past. And we repurpose them to make these tiles that have been currently under development and will enter like testing in order to make them viable for the market quite soon. So Bodybound is like where we're up to in the Isle of Skye, and there's a project that we've been developing to make these tiles into a hard composite. And we've now produced, like last month, we produced 10 of these tiles to give back to the restaurants that have been working with us all of this time. And we're also going to be presenting a really large installation of the tiles in Edinburgh Botanic Gardens this July, because a large amount of the research and amount of the development of the material comes from these art installation pieces that we've been working with different international partners. So this was our first development of the material, that it was using waste shell as just an aggregate with cement in LA for Muscle Beach in 2019. Which kind of shows our aim of the aesthetics of the material, but unfortunately still use cement, which is what we've been trying to avoid with firing the shells to also make lime, which is the alternative for cement. This is Oystering Room in the Taipei Biennale in 2020. And this is Oyster Readings, which will also be in Edinburgh this summer. And it's a table made entirely out of oyster shells that has kind of this performative engagement with it, where you go and eat an oyster and you discuss these issues. Yeah, so that's kind of a whistle-stop tour of our Climavore Builds project. We work with a number of partners alongside this development within Skye, and our craftspeople on Skye that we work with, including Imperial College in London. And one of the main kind of aims from now is that we fire the shells to make cement, but we are trying to make a like viable alternative to cement that's very low carbon. So we're looking into presses and hydro presses to try and not fire the shell and just press it into a hard composite, which is making really exciting steps currently at Imperial, just using milled shells and water to make these small tiles. And I guess our question now in both strands of pressing them or firing them is how we scale up our development and how we continue to like make jobs within Skye. So we have like a team of people in Skye working on all of the different projects, and how we continue to make jobs in order to develop it and scale it up in order to make many more tiles, as we have our recipe pretty sorted. And just for your information, these are some of the supporters that we've been supported through the year, and this is our details, our social media, our website, and an email if anyone ever wants to get in touch. So thank you. And sorry, I'm just looking for where I stopped screening. There we go. Sorry about that. And I'll pass it on to the next speaker. So thank you very much.
Hello, that's me. Hi, I'm Dawn Ellams. I'm just going to try to start sharing my screen. It's taking a minute. Great, so I'm going to just quickly give you an overview of the Future Fashion Factory project, and then I'm going to hand over to two of our industry partners who we funded research through. So Future Fashion Factory is a creative clusters project which is focused on supporting innovation within the UK fashion and textile industry. So our research works across all areas of the supply chain, so from sourcing through to new material development, retail, manufacturing and digital tooling for design and manufacture. So the Creative Cluster Programme was part of the UK industrial strategy to recognise kind of the value of the creative economy within the UK and to support innovation across the creative clusters. So within Future Fashion Factory, we have core research themes which we're working on. The project is a collaboration with UK industry, the University of Leeds, a leading University of Huddersfield are partnering, as well as Royal College of Art. So our core research themes that we're working on throughout the duration of the project, which is 5 years, are circular economies, aesthetic communication, late stage customization, education and skills, and data-driven design. The examples we're going to discuss later on in the presentation that I'll hand over to our industry partners are really fitted within circular economy. So within this core research team, we're focusing on reducing waste and environmental impact, creating new high-value materials from waste and sustainable and circular economy models for both design, manufacture and supply chains, retail, end of life. So within Future Fashion Factory, as well as the core research themes, we have these parallel R&D funding calls. We've currently completed the R&D funding calls now. We had 6 throughout the 4.5-year project. And the idea was to fund and support industry-led collaborative projects. So to bring together industry and academia to collaborate for innovation. So we've created these cross-sector collaborations to try and break down barriers between design, manufacture, different technical disciplines, and very much pushing the emphasis on industry to lead these projects. So it's not really about academic research, it's about this new collaborative approach. So the way that the funding calls worked were that industry would lead the application and they would identify their problem. They needed to partner with one of the 3 universities working within Future Fashion Factory. So that was either Huddersfield, Leeds or Royal College of Art, and they could apply for 3 levels of funding. So the proof of market projects were the smallest and the shortest. These were for £10,000 worth of funding over a 3-month duration. Proof of concept was for £50,000 over a 6-month duration. And the Innovation Challenge project was £100,000 over a 12-month duration. So the idea being very much to bring design, manufacture, academics and industry together to solve these problems. So you can see some of the projects we funded across the life of Future Fashion Factory. In terms of sustainable sourcing and manufacturing at scale, some of the examples are shown on the screen, but also if you just go to Future Fashion Factory, you can see we funded about 98 projects now, and over the next coming months, all the case studies will be starting to be uploaded. This has been really interesting just in terms of this new materials and specifically working with biomaterials and waste supply chains. One of the huge barriers is really about trying to take an idea and make it commercially successful or have a valuable application. So Salty Co is another project we're not presenting today, but just to give you an idea, they were focusing on regenerative farming and their fibre, although that idea and their business model was really interesting, it was really environmentally successful and a project that was very valuable just in terms of its approach. The product that was being produced was really low value. And so they came to Future Fashion Factory and we were able to link them with technical experts that could work out how to make their fibre applicable to fashion and textiles so it would have a higher value marketplace. A lot of the challenges that have been working with the companies really are about the consistent material source. So when we're working with waste supply chains and trying to put that into a commercial model, understanding regular and consistent waste supply that can be used within these technical processes that are needed to create fashion and textiles has been really challenging, as are the processes setting them up into a commercial scale, whether that be small, regional, place-based supply chains or larger supply chains. Those processes are often quite new. They're not very replicable. They're unstable when we try to scale up the manufacture. And then the supply chains are also really challenging when we're working again across different types of sourcing, new ways of manufacturing. Often the tooling that's required isn't within typical infrastructure. So the example of Saltico was really interesting because when it came to infrastructure, we recognized that their fiber behaves like wool. And so the UK has a lot of wool processing. And so within Future Fashion Factory, that's one of the things that we've questioned. If you can scale this up through existing manufacture, that's often not a consideration at the outset of these new material supply chains. So that's been really something that we've picked up with Future Fashion Factory. How do you ultimately scale up these innovations? And then the performance of the materials to go into commercial marketplace. There are standards. Often designers have been driving some of these innovations and they don't always understand the standards and the technical testing that's required. There's also a lot of pressure from brands and consumers to have certification and traceability, which they're not prepared for. So that's something that Future Fashion Factory has been able to support our innovators with. So I'm going to hand over now to our first speaker, Aurélie Fontaine.
Hello. Hello, everyone. Thank you so much for having us, and thank you for the introduction, Miriam and Dawn as well. So I'll be just sharing my screen right now. Okay. I'm just going to test that you can see the different slides switching because I have lots of lags before. Okay, cool, it's working. Amazing. So I'm Aurélie Fontaine. I'm the CEO of Osmose Labs. Basically, what we do is trying to bridge the gap between material science in fashion and the kind of concrete application of new biomaterials in that space. Because Don also talked about this before, how do we take biofabricated materials, so using biology and microorganisms to make concrete solution in that space for the fashion industry. So one example is our project Miko, which is a regenerative biofabricated leather alternative made with mycelium. For those of you who are not very familiar with mycelium, it's basically the root part of mushrooms that we can't see in the forest. And mycelium is a great organism. There's obviously lots of strains of different mushrooms, and they all do different things, but essentially what they do is to decompose lots of elements, especially toxic elements, and they are a great bioremediator in those ecosystems. So that's why it's a very valuable organism to work with. Just to give you a little bit of just a rundown of what we do. So essentially, we were funded by Future Fashion Factory, as Dawn mentioned, but also Innovate UK and the Greater London Authority. And what we do is to basically try to reshore the manufacturing of new material in the UK. Using mycelium, you're able to basically do a kind of what we call bioregion. So you're leveraging lots of different waste streams, which is obviously the topic of today. And how we do this is by taking waste from the agricultural sector, specifically the hemp production and hemp farming. First of all, I'd like to say about hemp that it's such a good fiber, and I'm really, really pleased to see that lots of different businesses are trying to take this to market to kind of try to replace cotton. It's a bast fiber, and the plant itself is very beneficial because it prevents erosion, which is a big problem we have in the UK, but also it sequesters a lot of carbon in the soil while it grows, and you can also harvest it more than once a year. So from the farms, we get whatever is left from the processing of the plant, which would be the hemp sheaves, and that is basically the food for our mycelium. Now, we also harvest that mycelium in local forests. We're based in Nottinghamshire, so that's great because we can work in partnership with other farmers in Yorkshire and Nottinghamshire. And then what we just need is one single cell of mycelium that we get in the forest around us. This single cell is brought back into the lab and actually fuels the whole production because you can replicate it with traditional laboratory protocols. So a bit about our material, it's very low impact because as opposed to cow leather and synthetic leathers, you don't need as much energy. Mycelium will kind of grow on its own and it feeds off its own moisture and own water. So you just like preload it with water and it will just like feed off that for the whole cycle. Then again, you don't really need to water it and you don't really need to, apart from having a kind of semi-warm environment, which is probably where most of the energy usage comes from, the process that we use to treat the fabric is very, very low tech. It's 100% vegan, obviously, biofabricated, takes 4 weeks to grow and is obviously able to be grown to order, which is actually what we're trying to do within the fashion industries to push materials made or grown to order. So we avoid wasting material that just sits in warehouses for a very long time. The great thing about this material as well, because it's bio-based, compostable, you can also tweak its properties. So you can do different colors, different textures. It's very, very easy to and versatile to change its surface. And in terms of the local manufacturing model that we use, we're developing some technologies to be able to streamline that. But as I said, our species are also UK native, and they're also non-genetically modified, which is a big ethical problem in bio-based materials, because some organisms have to be genetically modified to have some specific properties. We like to use non-genetically modified ones, because when you dispose of the waste during the production, you can actually compost everything. You don't have to worry about, is this organism going to leach out in the ecosystem and colonize everything. And as I said as well, what we're trying to do is to, beyond, let's say, upcycling that low value byproduct from the agricultural sector, we try to take our organic waste that's enhanced with those mycelium strains back to the farm. So what we're trying to do is do a full like circular model, like 360, where our mycelium is going back to the farm after it's created the leather, and it's going to actually bring nutrients to the soil. It's going to filter nitrates and all the toxic elements that you could find that prevents soil health and remediation. So to give you a little example, this is what our material looks like. On the left, this is the fresh mycelium. Mycelium is actually a network of hyphae, and these hyphae connect together and they will create a solid material in the end. What we do afterwards is we basically treat the surface with bio-based plasticizers, and then we go to the curing stage, which is essentially a very kind of low heat drying stage. And that's where you can actually change the surface of the mycelium leather. So you can add color, you can add waterproofing. But obviously we try to keep it kind of bio-based and as biodegradable as possible. And yeah, to conclude, so obviously we're part of the Future Fashion Factory Network. We've actually been working with Burberry onto developing this leather. We're also supported by the British Fashion Council. And we have worked for this specific project with the University of Huddersfield that's been doing all the kind of technical textile testing, and also the different kind of mechanical properties that our textile would retain. And we're also incubating at the Innovation RCA, which is the startup support system from the Royal College of Art. So thank you so much. I'm going to pass it on to my colleague, Rachel. Thank you for having us.
Hi, thank you. I'm just going to try and share my screen. Oh, but I've done something awful and can't get to it. Oh, no, sorry. I can't get to my slides. Sorry. Let me see if I can just try that again. Unfortunately, I can't get onto anything at the moment. I don't know if it's best if I start speaking. And maybe somebody else can share them for me. Okay. Dawn, I'm going to email them to you if that's okay.
Yeah, that's great. As soon as I get them, I'll share with you.
Lovely. Thank you so much.
Oh, well, he's just got them for you. You're fine.
Ah, amazing. Thank you very much. I'm not going to be able to click through, am I? So I'm just going to ask if that's okay. I'm really sorry, everybody. I'm Rachel Clues. It's a real pleasure to be here and to listen to everybody else's talks. I'm going to talk to you about my Future Fashion Factory funded project, which is to perfect biodegradable sequins. It's a year-long project and I'm 6 months into that at the moment, and I'm working with the University of Leeds, the Royal College of Art, Paula Noor, who's a fellow FFF member, and some additional industry partners based in Yorkshire and Humber as well. Could we go to the next slide, please? So the aim of the project is to perfect UK-made commercially viable biodegradable sequins made from renewable feedstock, including waste and byproducts. And this is going to be achieved through collaboration between researchers, manufacturers and designers, allowing the development and prototyping of these sequins and demonstrating how production can be quickly scaled up. The value chain from feedstock to end of life will be mapped and the sustainability impact will be evaluated. Can we go to the next slide, please? This project and all of my previous work with sequins has stemmed from the belief that sequins are completely fabulous, but an environmental disaster. And I'd say there's a clear industry need and a consumer demand for a more sustainable alternative to polluting synthetic plastic sequins. So conventional sequins are made from non-biodegradable synthetic plastics, and these cause huge environmental and health issues during manufacture, use and disposal. And the raw materials from which sequins are derived, including the PVC additives and the waste created by this plastic, massive environmental concerns. So I'm going to speak a little bit, to give you a little bit of context to the project. I'm going to speak a little bit about my background. So I studied for an MA in Fashion and the Environment at London College of Fashion back in 2012. And my project then focused on sequined party wear and kind of suggested that there's an imbalance when you have a dress which is decorated with plastic sequins that are going to last for hundreds of years, but the dress itself might only be worn for a few hours. So I started making bioplastic sequins, which you can see on the screen. Could you go to the next slide, please? I made a dress where the decoration had only last as long as the party. So once the party was over, the sequins could be dissolved and the natural dye that was contained within the sequins would come out, it'd colour the dress, and then the dress would be suitable to wear to a different occasion. And here you can see a dress sort of with 3 lives. So with the sequins on, the sequins partially dissolved, and then with the sequins completely dissolved. Could you go to the next slide, please? And then I set up a sustainable sequin company. My aim's always been to develop commercially viable biodegradable sequins, not the ones that dissolve in the wash. But I decided to start off using recycled plastic because it's something I could do straight away. And then the aim was to work on more sustainable options. So at the moment I use 20% recycled plastic, and doing that has benefits. It has reduced waste, pollution and energy use in comparison to conventional sequins, but obviously there's still massive problems with that approach. Could you go to the next slide, please? So I applied for an Innovate UK Sustainable Innovation Grant with Professor Ning Tao Mao from the University of Leeds. And the project then aimed to produce a prototype biodegradable polymer for sequin film. And at the end of the project, we developed 3 novel polymers that had got the characteristics we needed and were 100% free from oil-based fossil fuels. But there was still lots of work to do to engineer the polymers into a film that's suitable for sequins. So we're kind of bang up to date now with the project I'm on at the moment. So if you could go to the next slide, please. So I applied for FFF funding to continue working with the University of Leeds and Paula, and also the Royal College of Art and some other industry partners. So during this project, we've been looking again at the feedstock for the new polymers to see if it's feasible to use waste and byproducts as base for sequins, which we think it is. And I've been working with Ning Tao and Huayan at the University of Leeds to engineer the polymers to create a material that meets the requirements for sequins. So it needs to have that balance of stiffness and flexibility. It needs to be foldable without making white lines. It needs to be washable. And it needs to have the ability to be imprinted, so you can make cup sequins and also to add colour, which you can see on this slide we've just started to do. And could you go to the next slide, please? So the polymer film is going to be prototyped in a commercial setting in collaboration with our manufacturing partner, UKRI. I'm going to punch the sequins from the film and then wind them onto recycled, reusable and recyclable cardboard spools, which you can see on this image. And we've developed those with another partner, Cutting Edge, who are based up in Leeds. We've got sponsorship from Wilcon embroidery software manufacturer. So Paula and I are going to be working on producing digital sequin designs for pattern pieces. So we only need to stitch the sequins that are needed rather than cutting and sewing from sequined fabric, so to reduce waste there. I'm working with Dawn and Victoria at the Royal College of Art to map and evaluate the supply chain. So we've got a greater understanding, we're better able to communicate the sustainability impacts and also areas for further improvement. And it's going to cover things like the sequin waste and products that it could be made into, like the buttons you can see on the screen now. In summary, by the end of this very collaborative project, we hope to, the next one is fine. We hope to have made sequins from sustainable renewable resources, and a biodegradable end of life that are washable, are commercially viable, produced in the UK, able to scale, and backed up with data about sustainability benefits. And obviously the project's only possible because of the collaboration with all my wonderful partners. So thank you very much. And yeah, we see it's an opportunity to improve the sustainability of sequins, but also to make something that's really bright and beautiful and joyful. So thank you very much. And I'm going to hand over now. And I'm really sorry about not being able to get to my slides.
Hi, everyone. I'm the next speaker. I'm Rainika, and I'm just going to share my slides just now. Bear with me 1 second. Okay. I'm hoping you can all see my screen. Okay. So, hi, everyone. I'm Rainika, and I'm the founder of Houd. We are a biotech startup that's focused on utilizing allium waste, particularly onions in the family of garlic and shallots as well, to create innovative surface materials. And we're hoping to subvert, as many of my fellow speakers are, subvert plastics in some form or another. So just to give a bit of context on how the story starts, I, like again, many of the speakers are I am a designer, and my interest with onions started with natural dyeing. But upon sort of thinking about how robust they were when I needed to throw them out, I thought, there's probably a second life here. They are, in a way, nature's own form of single-use packaging. And I thought, what if I could apply that into design principles for the existing packaging that we have today? And so through much trial and error, I've sort of developed this material made from waste onion skins. And people always ask me why onion skins as opposed to some of the other feedstocks that are currently being utilized. And onion skins are quite interesting because, for one, they're a scalable solution to a problem that is massive. So onions are the base of so many cuisines we know and love globally. So their waste is global too, and in that sense, without risk of creating monocultures. To give you a sense of the scale of things, we generate about 66,000 tons of industrial onion waste in the UK per year. And industrial waste meaning coming from farms or sort of factories that produce onion-based products, from burgers to just dried onions or chutneys. And as it stands, there's no large-scale commercial use for them, aside from the odd bit of cow feed. So there's a large potential market there to use them. And what's even more staggering is there's a huge price tag involved with their waste disposal. So it costs about £23 million to get rid of them every year. So Houd has sort of come in to tackle all of these issues while creating a material that is home compostable. And we're still working on a variety of applications, but we've sort of identified food packaging as the one that we'd like to start off with. So just to show you a very crude prototype from a while ago that we developed of a soft fruit tray, so punnet box. We're still working in R&D on the many capabilities that onions bring. For example, they have antifungal and antibacterial properties and phenolic compounds that can preserve the shelf life of fish and meat. And to be able to integrate this into the existing packaging structure is where we're looking to go, so that we can tackle not only soft fruit, but meat as we go forward. And the cycle of which we're working with is pretty standard in the way of the circular economy, sort of take, make, compost, and work again. At the moment, our processing is we're still working on finalizing that. But similar to sort of what Alexandra has talked about, we are using some pre-treatments with our skins, bio-based pre-treatments, enzymes, in order to help break down some of the waxes on the skin itself, and then process that into our surface. It is then home compostable. And a fun fact here as well about onions is that with disposal, onions are quite hardy. They inhibit a lot of bacteria in compost piles. So through our process of taking these onion skins and breaking them down, we're actually allowing them to become further compostable when they do go through their end of life. And the way we've also designed it, as Dawn mentioned, scalability and sort of being able to make an impact with the innovations in a commercial sense is quite difficult. But we've sort of taken this idea that because onions are global, these products can be distributed around the globe with a low carbon footprint. So we intend to sort of license the technology to manufacturers around the world. And that's also currently what we're working on, is introducing our material into existing manufacturing techniques, giving them slight tweaks depending on our technology and development, but trying to use what is already there so that we can truly make the biggest impact with our material as it stands. And just to sort of close off, we have a partnership currently with the University of Strathclyde and their Advanced Materials Research Lab. They're currently helping to mechanically test and benchmark the material both through 3D structure, water resistance, a number of sort of standard testing parameters to ensure that our material can stand up to industry standards. And we're also partnered with Impact Central, an accelerator program for impact-driven startups. We're also currently in conversations with the University of Abertay's Food Science Department to continue to exploit what's in the onion. There's a high level of cellulose that we're looking to extract, which could provide some really exciting possibilities for films, as that's another area of the packaging space that is quite troublesome to replace from traditional plastics. But we're on the lookout to grow our R&D team at the moment and seeking investment. So if anybody is interested in getting in touch or finding out more about the project, I'd be very happy to speak to you. Thank you so much. I'll pass over to Kim for the Q&A.
Thanks, Renuka, and thanks to everyone. The fascinating presentations. It was generally quite a bit of interest in the chat. So I'm just going to carve a little bit of time back from the breakout rooms and try and work through some of these questions. Just scroll back up here to the beginning. So I think the first question relates to Alexandra's presentation. Was from Chip, and that was, can the dye be recouped from the biofermentation process, or will it then be unusable? I don't know, Alexandra, if you want to.
Hi. So yes, I was looking at the question. So we can recoup the dye. We haven't yet. We have been just started to think what we're going to do with it, but we can easily recoup the dye. It's just at the moment, because we are aiming to work as textile recycling, there would be different type of dye in the same vessel, and they would all be mixed up. So that would make it harder to recoup. So it's easy to recover them, but I think it could be quite hard to reuse them.
Great, thanks, Alexandra. Let's go next. So another question for you, Alexandra. We're sort of jumping back in time here a little bit, but from Rachel, is the developed fibre fabric washable, or does it absorb a lot of water?
So bacterial cellulose absorb a lot of water, which is what I said. But as part of our original project, we try to modify the surface property of the bacterial cellulose by using wheat extract from using wheat straw already. And we could make the bacterial cellulose a lot more hydrophobic. So that's something we could modify. Is it washable? We haven't yet tested that. But we have put it in a washing machine. So yes, it is washable in that sense, but we've never yet made a fabric that we have tried to wash over and over. But yes, the bacterial cellulose by itself can be washed. It's quite strong.
Next question from Meng Zhang. Hi Meng, good to see you again. Do you need to pre-treat the textile which contains the other polymers? How easy is it to isolate cellulose from different composite textiles? I think that's for you as well.
So I'm sorry, I'm just going to have to click on something because something is blocking my view. Yes, that's much better. So we can recover cellulose from viscose type textile very easily. And the presence of other contaminants such as elastane, polyester, nylon, polyamide is not a problem. And we've tested that. Basically, our enzyme will digest the cellulosic part of the mixed blend textile and leave the rest. So that's not a problem by itself. So depending on the origin of the cellulose, we may need a pretreatment. If we use man-made cellulosic fibers, we don't need a pretreatment. If we use cotton, we do need a pretreatment, a similar pretreatment as we use with wheat straw.
Great, thank you. I'm just scrolling down here. Question for Rosa, which I think has been answered. Where are we? So a question in relation to Myco from Amy. What are the end-of-life solutions for this product? Can it be reused, recycled, and what are the processes required?
Yeah, so it's a very good question. So actually, we've designed the material to be cold compostable. So you wouldn't need a particular facility to compost it or biodegrade it. The problem is it kind of occurs when obviously the material is used within the supply chain when it's made into products, because obviously there isn't any kind of clear routes on how to dismantle a bag or a jacket. And so there's lots of different components in those, especially shoes, as you might know, so over like 50 different components in footwear. So that's a big question, and that's actually what the Royal College of Art was looking at as well with Don's research, is how do we actually in the design stage take this material that is already biodegradable and compostable, and how do we put it in a design process and system that actually caters to the end of life. So I would probably ask this question to designers and brands, how do you get this done, essentially? Good question though.
Thanks, Ollie. I suppose this is kind of in the same vein. Another question for you. What products have you made so far using your leather? And would you be able to discuss about the plasticizers you use? I guess you kind of, to some degree, answered that, but...
Yeah, no, I replied, I think, to Dr. Lano before, but basically we haven't made any product because we are at this point interested in the material surface, enhancing it and trying to test it. I think someone mentioned certification, so that's basically what we need to get before we can launch and make products. And in terms of plasticizers, there's lots of new bio-based solutions that are coming into the market because the biomaterials are lacking this extra step because we've kind of, applied lots of synthetic backings, lamination to biomaterials so far. So that would encompass any plant-based leather that they are backed with synthetics, most of them. Probably Tree Kind is the only one I know of made in the UK that doesn't use synthetics. And then there's a couple of other ones, but that's basically each biomaterial need to develop their own bio-based coatings. And that's kind of the sad reality, because on top of making a material, we have to develop a coating, or we have to find a startup that does it as well. And plasticizers are varied. You can find plant-based plasticizers extracted from corn. You've got glycerol, you've got lots of different things you can use as well.
Brilliant, thanks, Orly. A question for Rachel now. When you say that your sequins are biodegradable, are they biodegradable in the environment, for example, if they fall off clothes, or in industrial composting facilities? And then there's a secondary part to this. Sequins obviously also having a metallic or sparkly effect. Is this possible using the materials you've developed? So from a sequin fan.
Oh, lovely. Hello, sequin fan. Yeah, it's a really good question. And we're trying to get the balance right between, and this is the really hard bit, but with two kind of opposing factors. And I don't know if other people are having the same problem with bio-based materials, but we want them to be biodegradable at end of life, but also want them to be washable. And they're kind of two things that are really competing against each other. So at the moment, the plan is to make the sequins biodegradable in industrial composting, because obviously you can get biodegradable glitter that will fall off in the natural environment and dissolve there, which is exactly the right thing for that to do. But if that was to happen if we made the sequins do that, then it would mean they would dissolve when washed, which is not what we wanted to do. So it's getting that balance right. And Dawn is also going to be looking kind of at the certification for that, and whether the certification exists for this kind of material for industrial composting, and also whether the infrastructure is there as well. In terms of the metallic and sparkly, we haven't looked at this yet, but yes, we're hoping that you can make sequins that are iridescent and do have a metallic effect. But at the moment, we're just trying to prove the concept by having a clear and shiny film.
Thanks, Rachel.
Thank you.
A question from Luke. This is for Orly again. There seems to be more and more companies making mycelium-based foams and leathers. Did existing patents make it difficult for you to get started in this space?
Yes, 100%. This is probably the biggest barrier to entry into the market, essentially because our USA-based competitors, Americans, own probably 90% of the patents already. And it's basically split between 2 or 3 companies. There's a clear monopoly in the IP in this sector. And so that's why and that's advice I can give to anyone trying to patent anything, maybe don't go the patenting route for your material, but go with the process or the technology, because this is where you can find the biggest freedom to operate. Because obviously materials, the process in which they're made, our material does not differ massively from other mycelium leather. It's actually how we make it that is very, very distinctly different. So, and also kind of know the landscape of your innovation and try to read or make a patent review, because it will solve a lot of problem down the lines of, inventing something new and then 5 years later realizing that you can't actually exploit the results from your invention.
Great, thank you, Orly. Next question is more of a general question from my colleague Liz. A lot of textiles manufacturing we have in the UK went offshore. Is there enough knowledge infrastructure remaining here, or do we need to build this? What about the skills needed too? So I don't know who wants to comment on that.
I can start. So in the area of my project, which is man-made cellulosic novel textile, some of the manufacturing would have to be built, but some is existing. So there is a factory making lyocell in UK. So I think it's a mixed, and it's about using what is available and moving on, but there would be a need to rebuild some of it.
Thanks.
Yeah, it's something we've looked at within Future Fashion Factory as well, so I can pick up on this. The aim of Future Fashion Factory is very much to look at reshoring and to support the industry, which is why the R&D stream was there. So actually we do work as well as with the micros and SMEs and emerging innovators. There's a lot of the projects who have been working with very established heritage mills and manufacturing that is still within the UK. But I do think more investment is needed, more support is needed. We have huge gaps in supply chains of what we can actually produce. So trying to get something through from fibre to product can be really challenging. It's not a very diverse range of materials that we're producing or working with either. Scale is a huge problem if you want short runs. Quality is a huge problem. Machinery we use in garment manufacturing is, perhaps not comparable with the quality in Europe and Asia. And then in terms of skills, I think, it's quite well documented in Scotland, they're facing an ageing workforce. That's happening more and more as well within England, and trying to make the sector appealing as a career. So to show development, to show that, it's a real value, it's a real skill, is quite challenging. UKFT are doing a lot of work with apprenticeship and trying to reframe the roles. So that's worth looking at. And I think also the Textile Centre of Excellence based in Huddersfield are doing some projects to look at apprenticeships and skills development, working with universities to have entry points and pathways. And also just in terms of the creative design courses, what skills do they actually need? What is the role that they're leaving university? And actually it's not just about creative skills, it's about linking with technical understanding as well, a lot of the time. So I do think it's quite a challenge, as well as looking at these new materials and the bioeconomy. Just looking at the textile infrastructure that we have at the moment, there are multiple challenges there.
Thanks.
Just wanted to add to that from a Textile Circularity Center perspective. I think there's also, in terms of circularity, there's other challenges of reshoring and offshoring, because I think it's not just manufacturing, but also thinking about the biorefinery and recycling of the waste feedstock and the processes and potential scale specifically for textiles and manufacturing that might be needed as well, which would be nice to connect to. Thank you.
Thanks, everyone. We're a little bit tight for time, as always. I don't know if you had anything else you wanted to add, Miriam, before we move to the breakout rooms. Or...
No, I think, we didn't, I think there's a few more questions. There's a lot of really nice comments in the chat just about ways to connect to really great initiatives. And I think there was just more questions about, for Alexandra, for using pure enzymes, or if you're using cells in your process, and also about fermentation.
So I've replied to the question and I said we use a commercial cocktail of enzymes, so there is no cells in it. And about the scale of fermentation, at the moment we can ferment up to 20 liters statically. And I think the comment mentioned submerged fermentation. And yes, this is an innovation and we are developing it. And for submerged fermentation, we've been successful, but we are at very small scale, which is half a liter.
Thank you very much. Well, I think I'd like to thank also everyone, the speakers, for excellent presentations. And I think, Kim, we're going into the breakout sessions now. Yeah,
I'd echo that. Thanks very much to everybody for both their presentations and for contributing to the Q&A. Just before we move into the breakout rooms, I promised I was going to put some links in the chat. One to our